Hi Falcons. Today we are going to be adding on to what we learned the other day with Miss Patterson, where we learned some rules for adding integers. Today we're going to start to talk about subtraction, and this is on page 132 in your workbooks. Okay, so the first lesson is equivalent equations. Consider the equation 2 plus 3 equals 5. Here's some more equations using the numbers that express the same relationship in a different way. So in elementary school, when you talked about these, you probably talked about fact families. Or you may have talked about number bonds. So we have 5 is our whole, and the parts that would make up 5 are 3 and 2. So 3 plus 2 is 5. When we look at subtraction, it is whole minus part. Instead of part plus part equals whole, we have whole minus part equals part. So you could have 5 minus 3 equals 2, or 5 minus 2 equals 3. So for each equation, I want you to write 2 more equations using the same numbers that express the same relationship in a different way. So I'm going to do number 1, and then I want you to do number 2. So number 1, if I look at the number bond, my whole is 8. It is made up of the parts 9 and negative 1. So I could write over here 8 minus 9 is negative 1, or I could say 8 minus a negative 1 is 9. Okay, same relationship there with those 3 numbers. So now you try the next one. Okay, I would hope you noticed that 7 was your whole, and your parts were negative 11 and x. And maybe you could figure out what the x was. But if I just leave it as a number I don't know, I could rewrite this as 7 minus negative 11 is equal to my x. Or I could say 7 minus x is equal to negative 11. So different ways of writing that same number bond and same equation. So again, knowing that addition is related to subtraction. Where addition is your part plus part equals whole, but subtraction is whole minus part equals the part. So here's an unfinished number line that represents a sum of 8. So how long should the other arrow be? So I want you to look at this, identify the whole and the part. When I look at this, I see that the part is made up of 3, and a positive 3 because it goes to the right. 8 is my whole. So to get from 3 to 8, what am I missing here? I am missing an arrow that would be 5 long. So that other arrow should be 5 to the right. So for looking at this equation, May writes 3 plus some number, and we can call that x, equals 8. But Tyler says when he looks at it, 8 minus 3 equals x. So let's look at the number bond for that. 8 is our whole. We have a part of 3, and we have a part of x. So yes, you could write 3 plus x equals 8. Or you could say 8 minus 3 equals x. Those are both correct. What's the unknown number? Well, we know that 3 plus 5 is 8, so 5. How did we know? Because that's how many spaces there were between where we stopped at 3 and the 8, right? So it would be 5. Okay, pause the video if you need to, and make sure that you get your notes written down before you move on. Okay, the next page continues with this, and it gives you 2 more unfinished diagrams that represent sums. So for each diagram, what equation would May write if she used the same reasoning as before? So remember, when May wrote her equation, she said part plus part equals whole. And what equation would Tyler write? And Tyler did whole minus part equals part. Okay, so when you're looking at them, look at it that way. Then figure out how long the other arrow would be and what number completes the equation. So this is what I hope you did. For number 1, my whole is 8. I know that part of this is -3, so I'm going to have -3 plus x equals 8 is how May would have wrote that. She knows one of the parts, she doesn't know the other. Tyler would have wrote 8 minus -3 equals another part. So how long should that other arrow be? Go back up and you can figure that out on your diagram here. We're going to go from -3 back to 8. How many would that be? Well, it's going to be 3 back to 0 and then 8 up to 8, so that would make 11. So my answer here, and I'm going in a positive direction, I'm going to the right. So for number 1, or diagram 1, the other arrow should be 8 spaces, or say 8 to the right for the arrow. Sorry, not 8. I'm going to confuse you. 11. Remember, we went 3 back and then 8 back, so that's 11 to the right. So what number completes the equation? Well, because it's to the right, that would be a positive 11. Okay? And again, we know that because that is the number of spaces from -3 back to 8. All right, so let's look at the second one. Number 2, May says, well, a part is 3. And she says, oh, yes, 3 plus some other part is going to give me -8, because my whole on this one is -8. Tyler would look at that same problem and start with the whole and say -8 minus 3 equals x. Okay, he would take the whole and subtract the part, and the part was a positive 3. So then what number completes the equation? So here I am after part at 3 to get back to -8. How many would that be? Well, I would have to go -3 to get to 0, and another negative. These are all negatives because it's going to the left, so that would be 11. 8 and 3 again is 11, but this time my answer is -11 because the arrow went to the left. Okay, pause the video again. Make sure you've got your notes taken down for that. And how we knew to draw the arrows right or left. You want to get from your end point of your part back to the whole. These number lines are still representing addition, all right, because we can look at the equation in 2 different ways. So we're going to draw a number diagram for -8 minus -3. So again, the first thing I would do is find that unknown number. So I'm going to do a number bond. Right here it's showing me that -8 is my whole, because that's what I'm starting with. I'm going to subtract a part, which is -3. This is the number I'm looking for, my x. So if I have a number line, here's my -5, -10, okay. Here's 5. It says we're going to go -8 is my whole, which would be right there, and I'm going to put my dot where -8 is. One of my parts is -3. So I'm going to the left 3. Now, what's missing? Well, to get there, I'm going to go to the left again 5 spaces, so this would be a -5. So negative 8 minus a negative 3 is a negative 5. Okay, so again, see how the number bonds help you find the missing parts as well as the number line can do that. All right, we're going to complete this table at the top with number bonds. Use number bonds if you need to. So I know that 8 plus negative 8, those would be my parts. I'm looking for the whole. 8 plus negative 8, those are opposites. You're always going to get 0. Okay, then 8 minus 8, well, that was from elementary. I know what that one is. That one's going to be 0 as well. But again, in this case, 8 take away part, which is 8, what's going to be over here? So 8 plus what gives me 8? 8 plus 0 gives me 8. Okay, so I want you to finish the tables. We'll come back and look at those and see if we can draw some conclusions, see some patterns here. So I hope you found that 8 plus negative 5, I have more positives, so this is going to be a 3. And I know that 8 minus 5 is also 3. When I look at 8 plus negative 12, I see that I have more negatives. How many more negatives do I have? I'd have 4, so this is negative 4. And 8 minus 12 is negative 4. Okay, negative 5 plus 5. Opposites are always 0. Negative 5 minus a negative 5. You may have needed to do your number bond here. Negative 5 is your whole. You're subtracting negative 5. Negative 5 plus what? Negative 5 plus 0 would give you negative 5. Okay, negative 5 plus 9. I know I have more positives. I have 4 more positives. And then again, negative 5 minus a negative 9. Negative 9 plus what? Think of it, I'm way over on the negative side, 9 spaces, and I want to get to negative 5. So what would I have to add to that? I would add a 4. Okay, negative 5 plus 2, I have more negatives, so that's a negative 3. And negative 5 minus a negative 2. Negative 2, how would I get to negative 5? I'm still going to have to go 3 more to the left, so negative 3. So you can see on each of these that subtracting a number is the same as adding its opposite. Subtracting 8 is the same as adding a negative 8. Subtracting 5 is the same as adding a negative 5. Subtracting 12 is the same as adding a negative 12. Subtracting a negative 5 is the same as adding a positive 5. Subtracting a negative 9 is the same as adding a positive 9. And subtracting a negative 2 is the same as adding positive 2. So subtraction is the same as adding the opposite. Okay, again, pause your video, make sure you have time to take that note. Okay, for your notes today, I want you, there's 2 things that are important here. Number 1 is that when we subtract with a number bond, what you're doing is you're taking whole minus part equals part. Where here's your whole at the top. Here's a part. We take away the part, we look for the other part that would be here. Okay, that's what subtraction is. We also found out today that subtraction is the same thing as adding the opposite. Okay, so 7 minus 5, we'll just start with a simple one, is the same as 7 plus, we're going to change it to addition and add the opposite. The opposite of 5 would be 7 plus a negative 5. Okay, negative 3 minus 8 is the same as negative 3, and we're going to add the opposite. We're going to add a negative 8. They would both be equal to negative 11, correct? So if we had negative 4 minus a negative 6, that would be the same as negative 4, and we're going to add a positive 6, which in this case, just keep using your addition rules we learned the other day. Different signs you'd subtract, which is 2, your positive is bigger, that would be a positive 2. Okay. On your problems for today, practice problems. They start on page 137. You're going to do 1 through 5. And what I need to tell you is on number 2, this section, when you get to these, you can do whole minus part. Think of it as your number bond. See if you can find the missing part. Change them into addition, right? Add the opposite. And then use your addition rules. We can also add the opposite. Okay, on these up here, we're kind of like solving a one-step equation when we do these. So I'm going to give you one of these so you can do number 1. A equals 6. Well, we remember one-step equations where you do the opposite. So here you could do A equals, we're going to add 9 to both sides. So A is going to equal 6 plus 9. All right, remember those? You can try that. And then number 3, I want you to remember when you are finding a percentage, you know the original, you know the result, you're looking for the percentage, you take the change and you divide by the original. Change and divide by the original. All right, and then number 5 is asking you to find the constant of proportionality. All right, that's subtraction. Have a good day, Falcons.